Hello everyone, my name is Suhang Limboo and I am from Namchi Government College, Kamrang, and this is our assignment. And for the assignment I have topic to explain laws of reflection and refraction derived from Fermat principle, and so here I go. Firstly, we'll discuss about who discovered the Fermat principle and when was it discovered. And firstly, it was proposed by a French mathematician named Pierre Fermat in 1662 as a means of explaining the ordinary law of refraction of light. And Fermat principle, it was initially controversial because it seems to ascribe knowledge and intent to nature. Until 19th century, it was understood that nature ability to test alternative path is merely a fundamental properties of waves. Now we will discuss about principle of Fermat principle. So Fermat principle states that light travels between 2 points along the path that requires the least time as compared to other nearby path. And from Fermat principle we can derive laws of reflection and laws of refraction, that's Snell's law. Now we will derive the laws of reflection using Fermat principle. Firstly, we will derive laws of reflection using Fermat principle. Here we need to consider a ray traveling from point P to O, that is from P to O, and it's going to point Q, making the angle theta 1 and theta 2. And we need to prove this theta 1 is equals to theta 2. T is equals to OP by V plus OQ by V, and by Pythagoras theorem we have got this equation 1. After this we know that Fermat principle, that is dt is equals to 0 and dt is equals to 0, and we differentiate dt by dx and we get the values this. And now we will prove laws of refraction. Here this laws of refraction is also known as Snell's law, and we have considered that the ray is traveling from point P to O and from O to Q, and making theta 1 and theta 2, and it has a distance d out here, and here x from M to O and d minus x from O to P, and it has a height h1 and here h2. And now we will derive the derivations. Here we need to prove mu1 sin theta 1 is equals to mu2 sin theta 2. Here time taken by a ray is t is equals to po by v1 and oq by v2, and similarly by Pythagoras theorem we have got this equation. And similarly by Fermat principle, dt by dx is equals to 0, and dt by dx, by differentiating dt by dx is equals to 0, we have got this equation. And after differentiating, for further evaluating, we have got this, and after this we know that sin theta 1 is equals to OM by OP, and sin theta 2 by OL by OQ. This is from figure, and here, and then we have got 1 by V1 sin theta 1 minus 1 by V2 sin theta 2 is equals to 0. We have just kept the value of sine in the equation, and we have got 1 by C bracket on C by V1 sin theta minus C by 2 sin theta 2 is equals to 0. Now we know that mu is equal to C by V, that is refractive index. And now result and conclusion of Fermat principle. From Fermat principle, it was found that in homogeneous medium, rays of light are rectilinear. It shows that light travels in a straight line in a medium having a constant index. The angle of incidence is equal to the angle of reflection, which is often called the law of reflection. So, this was the result and conclusion of Fermat principle. And merits and demerits of Fermat principle, that is advantages and disadvantages of Fermat principle. The most common formulation of the Fermat principle states that the light propagates in such a way that the propagation time is minimal. The Fermat principle is valid for any traveling wave. This is advantages. This is merits. Not only for light. In optics, the underlying equation is the wave equation, which describes all details of propagation. Geometrically, optics is a limiting case when wavelength tends to 0. The opposite limiting case when wavelength tends to infinity is the field of geometrical wave theory. That theory is based on the Fermat principle as well as the dual concept of rays and fronts. So, and other one is chemical waves can be described in details by reaction, diffusion reaction. And some recent formulation of the Fermat principle requires only stationary of the extremal instead of the stricter requirement of minimal propagation time. Now, special attention is paid to Atlantic surface where all the reflected or refracted path requires the same time, that is, the stationary holds globally. Non-Atlantic refraction is discussed too. The special example of refracting sphere is treated analytically. Finally, the shape of chemical lens is derived. This chemical lens is able to perfect image formation with chemical wave, that is circular front will be also circular after refraction. Now, application of Fermat principle. So, applications. From Fermat principle, it was found that homogeneous medium rays of light are rectilinear. It shows that light travels in a straight line in a medium having a constant index. The angle of incidence is equal to the angle of refraction, which is often called laws of reflection. Fermat principle refers to the fundamental law of optics that is used in the derivation of other laws of geometrical optics. One can make some useful observation about the conic surface based on Fermat principle. So, it was the application of Fermat principle, and thank you very much for watching my video till the end. Thank you.